Hey guys, Nick here with SparkFun Electronics, covering for Rob this week, who is out of town. So we've got some new products this week. We're going to jump in and check them out. It is Friday, and this is your Friday new product post. The first thing that we have are these red plastic enclosures. Now, these are great for outdoors or sort of weather resistant applications because they're made out of a hard plastic and they're about 3 millimeters thick on the edge. Also, they have this rubber seal on the inside that makes them dust resistant and moisture resistant. So any sensors that you have that might be sensitive to weather or to dust will be safe inside this enclosure. The whole thing kind of fits together with 6 4-millimeter screws, which are included. And once you screw that down, the rubber gasket forms a nice solid seal. You can see it also has these mounting flanges, which you've probably seen on weather stations or antenna ballons. Basically, the cool thing about these mounting flanges is that you can use a U-bolt, which isn't included here, but you can find it at any hardware store, and you can put a U-bolt through this and bolt it upright this way to a mast, like an antenna mast or a light pole. So that's what these are really useful for, and hopefully you'll be able to find a project that you can build into one of these enclosures. All right, the next thing we're going to talk about is this function generator kit. This is the FG085 Mini DDS function generator. This thing is a very cool kit. Once you put it together, it looks like this, but it actually comes as a parts kit like this. You get a little baggie of through-hole parts, which you will have to solder to the board. But the board itself already has all of these surface mount parts soldered to it. So you don't have to do any surface mount soldering to put this kit together. You just have to fill these through-hole component spaces with a few simple through-hole parts. The parts baggie includes some switches. There are 17 or 18 switches on this thing. It's got a full number pad, as well as some selector switches for waveform selection and amplitude selection. The output is a BNC, so there's a BNC connector in this bag. There are various capacitors, some headers, a USB jack, and a potentiometer. All these things you'll have to solder in place. I was able to do this in something like half an hour. It'll take some people longer, some people shorter, but it's really not a difficult kit to put together. Once you have those components soldered in place, there are also some standoffs. Just screw the standoffs through here. Make sure you have this soldered in place, your LCD display, and go ahead and take the plates, screw them to the standoffs, and once that's all put together, you end up with this nice function generator for your workbench. A function generator is a great tool to have. It can be, what a function generator actually does is it just generates continuous waveforms. So say you want to tune a sine wave, get a sine wave out of this thing at a specific frequency with a specific amplitude. That's what this tool is made to do. This specific function generator can generate 7 different kinds of continuous waveforms. It'll do a square, a triangle, a sine wave, a sawtooth up and down, as well as a staircase up and down. So that's 7 different continuous waveforms. It also has 2 other modes, one of which is a servo test mode and one is a servo control mode, where it actually outputs a servo signal with millisecond precision. So those are really handy things to have in a function generator that not everyone does, especially not one that comes as a kit and at this price point. It's just a really cool tool to have. So one of the things that you can do with a function generator is you can actually generate a square wave that'll act as the clock signal for a microcontroller or some other digital circuit. I figured this would be a good excuse to play with the Arduino's clock source and sort of give you an overview of what's going on with that little metal canister that's on the Arduino that we call a crystal. So what I've done is I've uploaded a sketch onto this Arduino that will blink these 4 LEDs in a binary counting sequence. So it'll start with just the bottom one, and then this, and then both of these, and then this, and it'll count up in binary. So I have it running with just the very smallest delay in between steps. So what you'll probably see when I plug this thing in is that the 4 lights here will just stay lit up. They won't hardly look like they're blinking at all. You may be able to see this one blinking because it's the one that blinks with the lowest rate, but overall it's going to be so fast that you can hardly tell that they're actually counting. So that's how fast it's running. It's running about as fast as the Arduino can count in binary. So what we're going to do now is I'm about to do something I don't suggest doing to your Arduino. I'm going to pull the ATmega328 off of the Arduino, and then I'm going to take, there are 2 lines on this chip that are marked X1 and X2, and those are the crystal lines. Now, what those do on the Arduino board is they go to an oscillating circuit that's based on a crystal resonator. And what that does is it essentially creates a square wave that the Arduino uses as sort of a drum beat to keep time, and that's how it knows how to execute each step in its programming. So what I'm going to do is I'm going to bend the X2 pin up off of the board, and I'm also going to bend the X1 pin away from the board, and I'm going to remove the X2 pin, which makes this chip pretty useless for anything but this at this point. And I'm going to put it back in the Arduino board. So now that that's been altered, I'm going to socket it back in, and what I've done is I've bypassed the oscillator that's on the board. So now I'm going to put an alligator clip on the pin for the clock source, and you can see all I've done is I've removed X2 and I've clipped onto X1, and I've pulled them both off of the board so that the oscillator circuit on board isn't involved anymore. Now, what you can do at this point is you can feed X1 a clock signal from outside the Arduino board. So I'm going to use our function generator as the clock source. Now, the Arduino is used to running at 16 megahertz. That's really fast. It seems slow when you think about today's computers and how fast their processors run, but in reality, you're talking about 16 million spikes per second. This actually can't generate a clock source that fast. This will generate a square wave well below that. We're talking about hundreds of kilohertz. So orders of magnitude less than what the Arduino is used to. So even though you couldn't see the lights blinking before, once I've hooked this up as the clock source, you should be able to see the lights counting, and actually counting rather slowly. So I'm going to go ahead and hook this up as the clock source. And I'm going to set this as a square wave, and I'm going to just push F/T to set the frequency, and I'm going to type in, let's start around 100 kilohertz. So 100 kilohertz square at 5 volts amplitude with 0 volt offset. And I'm going to plug in the Arduino, running the same code it was just running. And it's going to take longer to get through the Arduino boot sequence than it normally would because it has to execute everything slower. But once it's done that, you can see these LEDs are counting at a rate that you can actually see. So I haven't altered the code at all. There's no new delay in there. There's nothing new going on except for the fact that the instructions it was running at 16 million times a second, it's now running at 100,000 times a second, a whole order of magnitude slower. We can actually change that while it's running. It's running at 100 kilohertz now. Let's go ahead and change it again. Let's change it. Let's lower it down to 80 kilohertz. At 80 kilohertz, we'll reset, and you should be able to notice that it's running even slower now. The processor on the Arduino is the ATmega. Right now it's the ATmega328. So if you look at the data sheet for it, you will find that the slowest that it's supposed to be able to run is 32 kilohertz, which is dead slow for a microprocessor. Now, because I don't have the fuse bit set in this chip to allow an external clock source, it thinks it's getting its clock source from a crystal. So we may run into problems as we approach 32 kilohertz, but let's keep slowing it down. here's 50 kilohertz. Let's slow down a little bit. Let's take it down to 40 kilohertz and see what happens. We'll reset. Well, it stopped running at 40 kilohertz. This is an unhappy Arduino. When I boot it up, you can see that a couple LEDs start to blink and then it just loses its program altogether. So as we approach the bottom limit of 32 kilohertz, it's not going to run. But that just gives you an idea of what's happening when you give a microcontroller a clock signal. It's a heartbeat, and it tells the processor when to execute the next step. And while this was just a demonstration to just kind of play around with some LEDs, it's also a useful thing to do in some situations. If you have a digital circuit and you need to debug it, some chips have internal debugging where you can step through the instructions, and sometimes they don't. Sometimes you need to provide a slower clock source to be able to step through instructions at a slower rate and see how things work. Also, when you have a network of digital electronics and they all need to communicate, it can be helpful to be able to generate your own outside clock source to make sure that they're all on the same heartbeat and can communicate efficiently. So that's where you might use something like a function generator. Admittedly, this function generator doesn't generate a fast enough square wave to do any real processing, but it's a good demonstration of what you might do. Like I said, I was generating square waves just now up to 100 kilohertz. This will actually do a sine wave up to 200 kilohertz. Every other waveform other than sine wave is going to be slightly slower than 200 kilohertz because of the computational power it takes to generate those waves. So keep that in mind. If you need a function generator, if you're doing some RF application where you need to tune a circuit, or you're doing a digital application where you need to do some debugging, a function generator is a great thing to have on your bench, and this is a great one for the price. You can put it together in about an hour, and it works great. So definitely check this out. So the next thing we're going to talk about are these anti-static bags. These things are great for protecting any component you have that might be sensitive to ESD. You'll recognize them probably just because they're ubiquitous in the electronics world. Anything you order that's a sensor or a small digital part probably comes shipped in one of these bags. I know that we carry LEDs and some sensors that we ship in these bags all the time, and it's because of two reasons. One, it does provide protection from electrostatic discharge, which is awesome. It's a buried metal construction that offers this sort of Faraday cage protection that, you know, it conducts the static discharge around the bag and doesn't let it get through to the part. So it really does save parts from breaking from ESD, especially really sensitive parts like op amps and transistors, things like that, that can actually get broken by static. The second reason we use them a lot is because they're actually heat sealable. So we'll get them like this with no seal on top and just put them in a heat sealer, go across the top like that, seals them off, and it keeps dust and moisture from getting into the parts. So this is a pretty good sized bag. It's a 4 by 6 inch bag. Like I said, it's not a resealable deal. There's no Ziploc thing on top. So if you use these, you'll want to just fold it over and tape it. That'll work fine. You can also heat seal it if you have access to a heat sealer. We're selling them just because we use them in our shops all the time to keep transistors and op amps and things like that in. They're useful for organizational purposes. Also, if you're building widgets and selling them to people, it's always nice to be able to send them in these because you never know what your stuff's going to be subjected to in shipping, and you don't want it to end up on the other side fried by ESD. So definitely check out these bags on the website. And finally, we have brand new stickers. These are the latest SparkFun stickers. You may have noticed over the past year we've definitely rolled out some new graphics and things that we've used in our videos and on the website, and those graphics haven't showed up on stickers yet. We've still got the old sticker sheets, so we finally put out a new sticker sheet that has all of the new stuff on it. We've got the open source hardware logo, the flaming F5 key in honor of Free Day. We've got the According to Pete sticker, which you should put on everything you own. Pete loves to see his face on stuff. The Sharing Ingenuity sticker, Let Your Geek Shine. RTFM, you got to keep that one around. That's great to say what sometimes you just can't say to people. It's a good reminder. Read the manual. Don't bother me about it. Geek Pride. So get these stickers out there, put them on your projects, put them on your folders, let your geek shine. All right, as you can see, we've got plenty of cool stuff this week. If you got a project you need to keep it out of the weather, definitely check out this enclosure. If you've got some ESD sensitive parts, organize those in anti-static bags. Definitely check out the function generator kit. This is a great tool to have in your shop, and it's easy to put together. You can do it in no time. And of course, the new SparkFun stickers. So as always, there are more new products in the blog post, so make sure to check that out. And this has been your Friday New Product Post.